In this video, we'll be finding the derivative of some trig expressions, trig functions. So let's look at the first one. We have the derivative of 7 times tangent of 5x. Now I could put this 7, if it's a constant, you can bring it outside just like you can do with integrals and just take the derivative of that. So we can say, well, derivative of tangent is secant squared 5x, and then you multiply this by the derivative of 5x. That's using the chain rule. This will be a 5, and then the 7 is just comes along for the ride there, and then we multiply the constants. That's 35 secant squared of 5x. So 35 secant squared of 5x. That's the solution for the first one. And for the second one, in the same way, I could bring the 3 out in front and just focus on this. So you can see this a little bit better. Let's say 3, and then another way to designate, you're taking the derivative. I could do this using operators, d sub x. So I'm going to write it this way. And just so it's clear, I'm going to put it this way. So I got the constant in front. You can always bring the constant outside as long as it's a constant. You couldn't do it if this was an x. Let's just say x times this. You can't bring it outside. It's not going to give you the right answer. So with this method here, then you take the derivative of this expression, then it's times the 3. So it looks like this then. 4 multiplies to 3, or here. But then you're going to multiply by that 3 anyway. So that's going to be 12. And then we subtract 1 from that exponent there. And I can also I can keep it in parentheses, so I can put it right there. Sine cube of x. And then using the chain rule, I have to multiply this, or find the derivative of sine of x, which is cosine. So this is the final answer. Now you can do that in your head. You don't have to bring it out this way, but I'm just trying to clarify what's going on here. This is your answer. 12 sine cube of x times cosine of x. Okay, for this one again, I have sine of x plus cosine of x over sine of x. A couple of ways to do it at least here. I could use the quotient rule, which means I square this, and then it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. But I could also do this. Sine of x over sine of x, I could rewrite this as 1. Cosine of x over sine of x, that's cotangent. So now instead of taking the derivative of this is simpler. Take the derivative of 1 plus cotangent of x. So the derivative of 1, that's a constant. That's going to be 0. And the derivative of cotangent of x is a minus cosecant squared of x. And that's it. Now if you use the quotient rule here and simplify, you should come out with the same thing. But to me, this is a lot easier. Let's divide it out. Have a constant there. Derivative of cotangent of x is minus cosecant squared of x. That's the solution to that one. Okay, for the next one, we have the derivative, and then we have the cosine of this trinomial here. So the derivative of cosine, so focus on the main function. Derivative of cosine is minus sine. That's the first part. And then this stays the same. This is still going to be x squared minus 2x plus 4. Plus 4, so you have to take the derivative of that. Trinomial will give me 2x. And that's pretty much it. Now if you're working problems from the book and the answer in the back doesn't look the same. Sometimes they do some factoring or simplify. So here, for example, I can factor out at 2 here. I got a minus right there, so it'll be a minus 2. And this is x minus 1. And you still have this sign. I have x squared minus 2x plus 4. And you might see the answer this way. That's the answer for number 4. Now for number 5, we have the derivative with respect to x, as it is for all of them, of x times sine of x. So this is the product rule. And the product rule, of course, tells you that if you have the derivative of a product, say 2 functions, it's the first one times the derivative of the second. So this would be x times the derivative of the second sine x. The derivative of sine x is cosine. And then it's the second function, which is sine x, times the derivative of the first, where the derivative of x is 1. So that just leaves you with sine of x. So we've got x cosine of x plus sine of x. And that's your derivative for that one. Now for this one here, we have the derivative of 1 plus sine of x. So you can think of this as 1 plus sine of x to the 1/2 power. You can use the general power rule along with the chain rule. So the 1/2 comes out in front, and then we subtract 1 from the 1/2 there. Gives me a negative 1/2. And then we compute the derivative here, again using your chain rule. Derivative 1 is 0. Derivative of sine of x is cosine of x. This is one way to write it here. Or I could write it this way. This is also equal to cosine of x. And the 2 I can go in the denominator. And the negative 1/2 can bring this to this expression here to the denominator. It changes the sign. So I'd have 1 plus sine of x to the 1/2. Or I could, since the original problem is given with a radical, I could write it this way. 1 plus square root of 1 plus sine of x. I could give this answer this way. Or if I wanted to rationalize, depending on the instructions that they give you, I could multiply here by the square root of 1 plus sine x, and also the numerator by the square root of 1 plus sine x, and then this will get rid of the radical down here. Just depends on the instructions they give you. I'm going to leave it this way. If you're in a hurry, you might want to leave it this way. Number 7, we have the derivative of tangent of x over x. So these are functions. Now, if this were a 2 or 1 over 2, something like this, that would just be a constant. So this would just be the derivative of tangent of x, secant squared x, that's times that constant. But because it's a function of x here, I have to use the chain rule, the quotient rule. So let's do it this way. Got the derivative of a function of f, function of g, with respect to these are functions of x here. The formula tells you then you have a quotient. It's the square of whatever you have in the denominator, so this would be g squared. And then it's the denominator times the derivative of the numerator. That'll be f prime, that's derivative there. And then it's minus whatever you have in the numerator, that's just plain f, times the derivative of what you have in the denominator. So g times f prime minus f times g prime, and then you square the g there. So in this case, this is going to equal to, denominator is x, so that'll just be x squared here, and then it's x denominator times the derivative of the numerator. Derivative of tangent is secant square root of x. And then it's minus the numerator, which is tangent of x, times the derivative of the denominator. The derivative of x is 1. So that's going to stay tangent of x. So that's what you get for this one. Again, using the quotient rule here. Okay, for the next one, again, you have the constant here, so I could bring the constant out here and just take the derivative of cotangent of the square root of x and then multiply by the constant. Either way you want to think of that, just like the other one I did. So I know the 2 is going to be out in front, and then I focus on the derivative of cotangent of the square root of x. The derivative of cotangent is minus cosecant squared. I'll put the minus out in front with the 2, and then it's cosecant squared of the square root of x. So again, constant can go outside. Derivative of cotangent is cosecant squared of whatever this expression is here, and then using the chain rule, I have to take the derivative of that, which would give me, again, derivative of square root of x. Think of that as x to the 1/2. So it's 1/2, and then subtract 1 from the exponent, gives me a negative 1/2. You got that. So this is equal to, the 1/2 here and the minus 2 are going to cancel. That's just going to leave me with a negative. So this will be then a negative cosecant squared of the square root of x. And then I got x to the negative 1/2. That'll go to the denominator and become positive exponent. So this will be x to the 1/2, which is the same thing as the square root of x. And this is really your answer. So we can leave it this way. Now they say rationalize your answer. They don't want you to leave a radical in the denominator. I can multiply here by the square root of x and the square root of x. And then this is going to equal to square root of x times the square root of x. That'll just give me x. And I can put this in front so I don't get this mixed up with this here. So this will be a minus. This will be minus the square root of x out in front. And then I'd have the cosecant squared of the square root of x. And I can leave the answer that way. But we'll just leave it this way. Thanks for watching. We'll see you next time.